Alright, moving on to number 5. First, let's fill in some of these guys right here. This one right here on the left should be a 0, and this one right here should be a 6. This one should be a 16, and this one right here should be an 8. So we got everything filled in. So it says, the table represents the points on the graph of a linear function. What is the rate of change of y with respect to x for the function? So a lot of you guys tend to freak out when you see rate of change of y with respect to x. Basically what that's asking you is, what is the slope? What is the slope of the function of y with respect to x? Or, excuse me. So right here we can either do it manually, which is doing m is equal to y2 minus y1 over x2 minus x1. You can do it that way, or we can do it the shortcut way. I'm going to go for the shortcut way this time. So we're going to go to Desmos, and we are going to start you can either fill in the old table that you had if you still have it there, or you can just do a new one. I'm going to do a new one since I deleted mine. So 0, 3 at the bottom, 6 under that, and 9. And then on the right we have 4, 8, 12, and 16. So that's not that bad. And then we see the points right here. We want to find the slope of those points, so we can just use y1 worm. So we're going to do y1, and then we're looking for the worm, mx. 1 plus b. Boom! We already have a slope. It is m. So our m here is 1.33. Now I already know this because I'm pretty good at determining which which specific fractions turn into what decimals. Just like you guys know, 0.333333 is just 1/3. Well, I can just recognize that 4 divided by 3 is 1.333. So if I go back to the paper, I can write either 1.33 with a bar up top as my slope, or I could do m is equal to 4 over 3. And I figured out what my rate of change was, which was extremely easy when you're using Desmos. So woohoo for that, I guess. Moving on to number 6. We have, write the equation of a line containing the point 3, negative 2, and perpendicular to the line. Now the line that they want us to write in here is actually y is equal to negative 1 over 2, x plus 6. There we go. In slope-intercept form. So first of all, let's write down what it wants us in the type of form it wants us. It wants the line written in y equals mx plus b. That is a form that you should be very familiar with. You know what is expected of you. Now what changes on this one is that we want an equation of a line that contains the point 3, negative 2, and it has to be perpendicular. Now when we're talking about perpendicular, we're talking about our slopes being opposite reciprocals of each other. And that's just a very fancy way of saying, you've been taught this, but I call it the flip and switch. What I mean by that is, let's write down our slope right now. This is the slope that they were referring to right here. This negative 1 over 2. So, let me rewrite that, negative 1 over 2. Let's do it in purple. So, it says here that our slope is negative 1 over 2. So what that means, flip stands for flipping the numerator and the denominator. So let's do that right now. We're going to flip the numerator and the denominator. Negative 2 over 1. And then the switch means that we're going to switch the sign from negative to positive. So we maintain it, we're going to go like that again. It's 2 over 1, but it's now positive. I got rid of the negative. So another way of writing 2 over 1 is just 2. So your slope that you're supposed to be writing in there should be 2. So next to the x, there should be a 2. Can we cancel out some answers doing that? We sure can. We can cancel out b, and we can cancel out d. So we've already made our shot 50-50, which is pretty good odds. So it says it has to go through the point 3, negative 2. And since we have slope and we have a point, we can use point slope form. Let me rewrite down what point slope form was, which is y minus y1 equals mx minus x1. And if I want to fill everything in, I know that my y1 and x1 are right here. Let's label those, x1, y1. Beautiful. 3 and negative 2. So negative 2 is our y1. So we're going to do y minus a negative 2 is equal to, our m is supposed to be a 2 because it's perpendicular to the other line. So we're just going to put a 2 right there. X. And then minus, what was our x? Our x1 was 3. So we're just going to do minus 3. And then it looks a little janky, of course, so we're just going to turn this into y plus 2 is equal to 2 parentheses x minus 3. Alright, now it looks like the formula that we're used to. It doesn't look janky in any way. Now we're going to try to solve for y because we're trying to get it in y-intercept form, which is what it was asking for. I mean in slope-intercept form. So first thing we got to do is distribute. Right here we have parentheses. We need to distribute. So let me change the color on this. 2 times x will give us 2x. 2 times negative 3 gives us negative 6. We rewrite what's over here. Try not to get lazy and not rewrite it down because that's how we forget things often and then our equation comes out wrong. Okay, so we have 2x and minus 3. We're trying to get y by itself. So all we need to do is subtract the 2 from, that looked a little weird. Subtract the 2 and subtract the 2. These guys cancel out. I'm going to switch out to another color. And we're left with y is equal to 2x. And then negative 6 minus 2 is negative 8. So right there, we seem to have found our equation in slope-intercept form, which means that it can't be this one right here. It's got to be A. It's got to be. So it looks like we're just chugging through this quickly, which is awesome because that can get you to study this well and do really good on your retest to get that 70. So let's move on to the next one, number 7. It says the table below shows data collected over the last year. Now this right here should say number of students not using. So let's fix that right there. It's not. Or you don't even have to cancel that. We can just do, let's make it a thin addition right there. We can just point to this right here and say not using Desmos per class. So it's the number of students not using Desmos per class versus the percentage of students passing the STAR in that class. So these are the numbers that we got last year based on the number of kids that were not using Desmos every class and seeing how that affected their scores whenever they tried to take the STAR. So right here we have 28 students, that's almost a whole class not using STAR, and 35% of those kids passed the STAR. Okay, so that's a pretty low percentage. And then we're at 20 kids not using it with 27 passing, 26 kids with 12 passing. So as you can see, those are pretty dismal or terrible percentages of passing the STAR, so that's not good. And then we start going to the classes that have only 3 kids not using Desmos, which gets a 90% pass rating. That's really awesome. And then 8 kids not using, 82. 0 kids, not a single child in that classroom was not using Desmos, and 95% of them passed the STAR. So that's tremendous. So if we were to put this information onto our table on Desmos, we would see that we would get our slope, our b, and then we would also get one more parameter called the correlation coefficient, this guy right here. And the correlation coefficient is measured, or is demonstrated using the letter R. Now on this one, it should say that R is equal to negative 0.95. Negative 0.95. So does this represent a strong positive negative or a weak positive negative correlation? And what that means is it a strong positive correlation or a strong negative correlation? A weak positive correlation or a weak negative correlation? And that's something that we can kind of enlighten ourselves with. So we're going to create a little number line right there, and on this side we'll do the line, and then here we'll do the other line, and then down the middle we're going to have 0, this one's going to be 1, and this is going to be negative 1, and then between those two we're going to have, oops, let me do a better one. Right there we're going to have 0.5, and then here we're going to have negative 0.5. So basically what I taught my students is that anything that falls within this right here is called a weak correlation. Anything that falls within this right here and this right here is called a strong. And this one right here is strong. Okay, that looks weird, but that's fine. Okay, now what matters is that on, I'm going to make that one purple, this side right here to this side is negative, and then let's make it let's go with, we'll go with pink. This side right here to this side right here is called positive. Oops, can't spell. Alright, so we got negative on the left, positive on the right. Weak is the two middle parts, all the way to negative 0.5, and 0.5 is weak. Anything above 0.5 on either side is considered strong. So 0.95 falls somewhere along right, negative 0.95 falls somewhere maybe right there. Negative 0.95. Okay, so that obviously falls on the strong side. So we can automatically delete weak and this one right here. And then it falls on the negative side of things, so we can also take out the strong positive. That means that our only possible answer has got to be B. So there is a strong negative correlation, hint hint, for not using Desmos, leading to very bad scores. The more students that won't use Desmos, the smaller the percentage of students that pass the STAR in that class. So make sure to keep that in mind, guys.